Okay, hi. In this video, my group confirmed by Kenneth Fernández, Adriana, Jarquin, and me, Juan Pablo González, we're going to talk about the site pattern visitor. So imagine that you have a complex data structure. Over time, you need to perform different operations on it. And these operations keep increasing as your application grows. You'll soon find that keeping track of all these operations and their variations become challenging. This is where the visitor pattern comes in handy. The visitor pattern allow us to separate these operations into their own classes, making it easier to manage and add new operations without modifying our structure. So let's break down how the visitor pattern works. You have five main components: the client element, concrete element, iVisitor, and concrete visitor. Let's start with the client. The client interacts with both the structure and the visitor. It's responsible for creating the visitor and applying it to the element. So next we have the element. Basically, this represents the root of the structure. It's usually an interface that defines a method called accept. This accept method is implemented by all components in the structure. So then we have concrete element. And this represents each individual part within the structure, like nodes within a tree. Each concrete element has an accept method that we will call the appropriate visitor method when needed. So then, let's talk about iVisitor. This is an interface that defines the structure of the visitor itself, and it must have a method for each different type of element in our structure. And finally, concrete visitor represents an actual implementation of the visitor. It contains the operators that will act on the elements. So we can create as many concrete visitors as we want, each one representing a different operation of the structures. Now, let's see how this works in sequence. So first, the client starts by creating the structure or element. Then, the client creates an instance of the visitor to use on the structure. Next, the client calls the accept method on the element, passing in the visitor. The element tells the visitor which method to use for processing it. Then the visitor analyzes the element using the visit element method, repeating the accept method process for all child elements. And this process repeats as the visitor traverses each part of the structure. So let's see more detail. In sixth place, concrete element A calls the visitor visit element A method to process itself. Then the visitor moves to concrete element B and calls visit element B. Fine. Okay. Next, the visitor continues through each element until the entire structure is processed. In the end, if an operation produces a result, the client can retrieve it through an optional method like getResults. So, one of the benefits of using visitor design pattern is that by separating operations into visitors, we keep our structure clean and organized. Adding new operations doesn't require us to modify the structure itself. Just we simply create a new visitor class. This flexibility is especially useful in large applications with complex data structures. Now, now that we understand the visitor pattern basics, let's look at some common scenarios where it's especially useful. For example, file systems. When working with a file system, you often need to perform various operations on files and directories. The visitor pattern allows you to define operations like searching, compressing, or scanning for viruses without modifying the structure of the file system itself. Next, on document processing. In document processing applications, you might have a complex structure with elements like paragraphs, tables, and images. The visitor panel lets you to create operations like exporting, printing, or formatting each element types separately without changing the document structure. In third place, in compiler design, you often need to traverse an abstract syntax tree representing the code structure. The visitor pattern is perfect here for implementing operations like type checking, code generation, and optimization, which you can add as separate visitors. Finally, in e-commerce applications, you might have different types of products and discounts. The visitor pattern allows, allows to apply various discount strategies or pricing calculations independently, making it easier to adjust pricing logic without changing the product structure. So as you can see, the visitor pattern is highly versatile and helps keep complex structures manageable, regardless of the application.
Buenas, mi nombre es Adriana Jarquin. A continuación voy a presentar la implementación Visitor al programa de facturas. Bueno, utilizamos el patrón Visitor en este programa para calcular los impuestos modificados, la clase de factura, para que en lugar de tener tres métodos, uno por cada clase de productos diferente, para calcular los impuestos, ya que se calculan los tres de diferente manera. Entonces, creamos una interfaz visitor con tres métodos, visit cada uno para los diferentes productos. Luego creamos la clase impuesto visitor, implementando la interfaz visitor y con una instancia impuestos para poder devolver el resultado del impuesto sin importar la clase de producto. Y finalmente a cada una de las clases se les agregó un método hacer para que acepte al visitante y así todo el funcionamiento del patrón finalice. Y con esto concluyo el...
Alright, now let's make this part a bit more interactive, less imagined. We are in a software design class, and I want you think along with me as we discuss the visitor pattern. Let me ask you this. Why do you think using the visitor pattern will be helpful when working with a complex object structure like a file system or these geometric shapes? Exactly. The main reason is that it allows you to add new operations without modifying the existing object classes. Following the open-close principle, our classes are open for extensions, but closed for modification. Imagine we are building a graphics applications with classes like circle, square, and triangle. We want to add an operation to calculate the area and another to export the data to JSON file. If we put these methods directly in each classes, we end up cluttering our classes with specific logic. Now, what will happen if we later need to add an operation to drag the shape on the screen? Exactly. We will have to modify each class again. With the visitor pattern, we can add these operations externally, centralizing them in visitor objects. Let me show you one this will like in code using the visitor pattern. In this example, shapes like circle and square only need to implement the offset method, and the visitor can handle the complex operations. So, here's another question for you. What do we gain by implementing the offset method instead of putting all the operations directly in the shape classes? That's right. Our classes remain cleaner and more flexible because the operations are managed externally. Now, I have a challenge for you. So think about if we wanted to add a new operations called draw. Would we need to modify the circle and square classes, or could we simply create a new visitor called draw visitor? Exactly. We will use need to create a new visitor. This is how the visitor pattern helps you keep our code extensible. I hope this exercise was helpful in better understanding the visitor pattern. Think about how to make apply it in your own projects to add functionality without modifying your model classes. Thank you very so much for your attention.